Rationalizing denominator. Of course, for radicals. The two type of questions that we're going to work on right now, and I'm going to name them again, question 1 and 2 for the second part of the class. Example 1, I'm going to talk about if you have a radical in the denominator. Let's say you have radical 5. On the numerator, you could have had radical, non-radical, anything. Numerator doesn't matter. If you have a radical in the denominator, you should simplify. The process of simplifying calls rationalizing to get rid of radicals in the denominator. I'm going to give you rules or algorithm of how to get rid of radicals in the denominator. You cannot just get rid of it by removing it. You need to remove it by using some techniques. We're going to work through those techniques. And then sometimes it's not only one item in the denominator, you would have more. Like let's say you have anything on the numerator, like radical 2. Again, numerator doesn't matter. Could be number, could be radical. But in the denominator, let's say you have 1 plus radical 3. You have a binomial. You have 2 terms in the denominator, added or subtracted there. So that's why you need to come up with another technique. I'm going to show you technique for the first example, and I'm going to show you the technique for the second example. For the first one, and again, in this class, you are mainly working with the square root. So we are not worried about cube root or fourth root, square root of a number in order. Tell me, how do I undo square root? By multiplying it by another square root. If I had square root of 5, top and bottom, if I had that square root of 5 times the square root of 5, what is the square root of 5 times the square root of 5?
The square root of 25.
Square root of 25, which is square root of 25 is what? 5. So by multiplying the denominator by root 5, I was able, and you see I have the same copy of the same thing. You don't need to multiply them on every time, say, oh, it's the square root of 25. You can say, oh, 5 and 5. Same copy, one comes out as 5. Square root of 5 is square root of 5 is 5. Yes? But you are not allowed to only multiply the denominator. You have to multiply the numerator by the same thing. So that's like a 1. I mean, I'm not allowed to multiply a denominator by something without considering the numerator. This is like a 1, so I'm multiplying a 1 by my fraction, so which is okay. And that 1 is a radical 5 over radical 5. The radical 5 in the denominator helps me to get rid of the radical in the denominator. And the numerator, I really don't care what the output is. Could be with radicals, could be without radicals. So it's important that my denominator is radical free. Okay, so 3 times radical 5. Is it radical 15? Is it 15? Or is it 3 root 5? 3 root 5. They are not the same thing that you multiply them together. One is a number, and one is a number on the radical. There are 2 different things. When you multiply them, 3 times root 5. The other type, and I want to give you back to back so you would see their difference immediately, and then we're going to apply examples here. Or apply what we learned into examples that comes up. Okay. Now you have, do you see the difference of this one and the previous one? Observe it. For the previous one, you only had 1 radical. For here, you have a number and radical. Could have been radical and a radical. Could be, yeah, combination of a radical with something. That something could be added a number or added a radical or subtract. So you have 2 items, not 1. You multiply top and bottom by What is that opposite of thing means?
1 minus radical 3.
1 minus radical 3. Remember, anything you do with the numerator, denominator, you have to apply to numerator. Do you know what do they call that opposite?
Reciprocal.
Conjugate. That calls conjugate. The conjugate means if it's added here, you would change it to subtraction. If it's subtracted there, you change it to added. So one of the signs would change. So that was 1 plus root 3, now it's 1 minus root 3. And you multiply with top and bottom. Okay, I'm gonna remove these lines. So what I want you to do, I want you to let's multiply the denominator by denominator because I want you to see how the radical would disappear here. So let's just do 1 plus root 3 times 1 minus root 3. How do I do the process? What do we call that?
Foil.
Foil. First times first, so that's for the F. O for the outer. I for the inner. And then L for the last. Foil it. So what is first times first? 1 times 1? 1 times negative root 3? Root 3 times 1?
Root 3.
And then here's the last one. Look at here. Negative root 3 and positive root 3. What is that?
Negative root 9.
Negative root 9. Or from now on, if you see a same thing, multiply by, like the radical that are the same, multiply. What is radical 9?
3.
3. I have radical 3 times radical 3. Can I just say 3 without multiplying them? Radical 3 times radical 3. We said this repeat of the same thing would cancel the radical. That's like under radical, you have 3 times 3. The same copy, one comes out. So radical 3 times radical 3, you can think of radical 9 and then get 3 out, or just say they are the same thing, I can remove the radical. I put a negative sign because it's positive radical 3 times negative radical 3. Positive times negative is negative. Radical 3 times radical 3 is 3. Or radical 3 times radical 3 is radical 9, which radical 9 is 3. Up to you. So what cancels? So then one is positive radical 3, the other one is negative. What is 1 minus 3 now? Negative 2. So I have a fraction. In the denominator, I have negative 2. 1 minus 3. So now I deal with the numerator. So on the numerator, what do I have? I have root 2 times, remember that you put the invisible parentheses when you are multiplying and make them visible. 1 minus root 3. Root 2 times 1 is 1 root 2, which is just root 2. 1 times anything is itself. 1 times root 2 is root 2. Minus, this is positive times negative, so I know it's subtraction. Root 2 times root 3. Is it obvious that it's root 6? Root 2 times root 3, when you are multiplying radicals, you can multiply underneath. Like radical 3 times radical 3 is radical 9, which is 3. Radical 2 times radical 3 is radical 6.
So we can consider them like terms?
There is a rule for multiplying radicals that say radical A times radical B is radical AB. Or if they are multiplied, you can separate them. So basically, same thing with dividing. So radical A over radical B is the same thing as you put radical over the whole thing. That's not the same with adding and subtracting. So that means radical A, as we did an example before the break, is not the same as radical A plus or minus radical B is not the same thing as you were adding them under radical. So that's not true for adding or subtracting, but it's true for multiplying and dividing, where you can put them, multiply them together. Radical 2 times radical 3 is radical 6. So then on top, as of multiplying those two together, I have radical 2 minus radical 6. That's the answer. Someone might say like, oh, I like to distribute this negative to the numerator. I mean, that's fine. Or you can say, oh, I like to pull the negative to the numerator and not have any negative on my denominator. That's fine as well. Someone might say, oh, I don't like the parentheses. I want to distribute the negative in here. So then that's negative radical 2 plus radical 6 over 2. Do you see distributing the negative makes this one negative, the next one positive? Yes.
It's negative parentheses square root of 2 plus square root of 6, because you took out the negative.
No, because I brought this negative from the bottom to the top. I said, instead of having the negative in the denominator, let's just distribute it in the numerator. Then I turned the positive radical 2 into negative radical 2 and radical 6. And someone might say, oh, I like to rearrange them, that radical 6 that is positive to be first, and radical 2 that is negative to be next. So anything from here on is the simplifying. This could be an answer. This could be an answer where I move the negative up. Distributing the negative makes this one negative and this one positive. And then rearranging, bringing positive root 6 first and then minus root 2 next. These are all the same answers, like the same correct answers. So it's just the process of simplifying.